Hi, Theory 4. We come to chapter 27, which deals with post-tonal theory. And this is going to be, quite frankly, the toughest video for me to make because there's so much to talk about. And also because it's very mathematical, and I am no math whiz. And so this has always been the most difficult part of theory for me to understand, let alone try to teach. But I'm going to give it my very best shot because we do need to talk about this. What we're talking about in set theory, sometimes called atonal theory or set theory, is reinterpreting pitch names as numbers and vice versa, so that the pitches become numbers of integers that can be used to create music. There's a lot of ways that this is done. To try to facilitate this a little bit, what I've done on your Canvas page is to reproduce my lecture notes so that you can read them over. I'll be working from those right now, but I thought it might be helpful to be able to go back and look at this. I also put a recording of the work by Arnold Schoenberg, the piano piece, Opus 11, on the Canvas page so you can hear what the end result would be, or might be. The first thing we want to talk about is called the pitch class. A pitch class is a category of notes including all possible enharmonic spellings of a pitch. So for example, let's take C. Okay, C is also B sharp. C could also be D double flat. It doesn't matter how it's enharmonically spelled, it's the pitch class C. And the same thing is true of all the other notes. We could have E flat. It could be spelled D sharp or E flat or whatever else you want to think of. It's still the pitch class E flat, which gives us 12 pitches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, of course, before we get back to where we started, to the pitch class, in this case, C. So we've got 12 pitch classes, and they are numbered 0 to 11, starting on C. So in the textbook, there's an example here of how this is done. We typically use a clock face. This is on page 510. If I was more technologically conversant, I could do this better. But there's the clock face, and then you write your notes to each corresponding number. So C, in this particular form of set theory, will always go at 0. So if your next pitch was C sharp, of course that would go at 1. If it was D flat, you would also go at 1. The next note would be D, or any one of its enharmonic equivalents would sit at 2, and so on. So out of this, we try to figure out this very difficult music by using sets. We call these basically pitch class sets. Now, in atonal music, or pantonal music, if you prefer, sets are grouped by various relationships. So we look for a few things. We look for melodic motifs. We look for phrases. We look for rhythms. We look for harmonies, and so on. Now, we're going to use the Schoenberg piece that's in the textbook. This is his piano piece, Opus 11, number 1. Here's just the very beginning of it. I'm only going to play the first 3 measures. Now, you'd be hard-pressed to find a tonality in there, although it's not quite as crazy as it might be. But, and I say crazy in a loving way, All right, so let's pick it apart. First of all, we have these three notes, B, G sharp, and G. Okay, those might be said to be a motive, a melodic motive. Now we could also look at the first phrase, which sounds like this. Which by itself is kind of lovely. And we would say this could be the first phrase. We would then order those notes into a pitch class. We can also look at harmonically. We have this first chord, if you will, followed by this one. The first chord is G flat and F with a B. The next one is a B flat and A with a D flat. So let's now take a look at this. Our melodic motif is B, G sharp, and G. Our first phrase consists of B, G sharp, G, A, F, and E. Our opening harmonic set is G flat, F, and B flat, A, and D flat. Now, here is how I've written this in the text, and I'm not sure how this will look on the page, but you can see, hopefully, how I've notated that. You'll notice that the pitch classes are bracketed. They have parentheses around them, and the letter names are separated by commas. That's how we would write them. Now, sets, by their very nature, do not include doublings. So if there were two G sharps, we would only use the one G sharp. If we came back to the G sharp before we completed that particular phrase, we would just say G sharp 1. So we don't use doublings to create these sets. The other thing is that by their very nature, they're unordered. So our melodic motive could be G sharp and G natural, or we could call it G sharp, G natural, and B, or any other ordering we want to. Doesn't matter. Now we put this all together. On our clock face, we use what's called C-based fixed 0. So on our clock, 0 sits at the 12 o'clock position, and that is where, in set theory, I hesitate to go too much further with this, but when we start talking about tone rows, it's a little different. In set theory, C will always sit at the 0 at the top, which is where 12 o'clock would be. So then we would add our pitches in around. C sharp would be 1, D would be 2, and so on. Now, if we do that and we complete that clock phase with all of our possible 12 pitches, here's what we get. Our pitch set of B, G sharp, and G becomes 11, 8, and 7. Now the next little thing that we have to do is to place these sets in what's called normal form. And this basically means arbitrarily ordering them in a way that is the most compact, the most direct and compact. So most of the time you can figure that out by looking at the music, but if not, here's how it works. You write out all possible ascending ordering within an octave. So there will always be as many ascending orderings as there are notes in the set. So, okay, let's say we're going to take our B, G sharp, and G. So within one octave, we would have B, G, then G sharp. So we could say that is one ordering of the set. Now, what we try to do is to take what's called the outside interval, which is the distance between the first and last note. I sneeze. Pardon me, allergies. Between the first and the last note of the ordering. In this case, that is the distance of a sixth. Those are 6 pitches apart. We try to work this down to the set which has the smallest outside interval. So if we use our set of B, G sharp, and G, our normal order, that would be the smallest possible compact version of this, would actually be G, G sharp, and B. Now, playing them where I am on the piano register, that's G4, G sharp 4, and B4. Okay, so we've gone from here to the most compact version of the set. Now, sometimes there's a tie for the set. I don't really want to get into that right now, but it's in the textbook, and I think you should take a look at it. But I'm running out of time on this video, I can see, so I'm going to try to wrap this part of it up. To determine the normal form of a PC set, list the ordering of the PC set, that was Freudian, I don't know, but of the PC set in ascending order. And then the number of ascending orders is equal to the number of members in the set. So if we've got 3 notes, there's 3 ascending sets. And then take the one with the smallest outside interval, and that will be your normal form, and then we get into breaking ties and so on. I'm going to stop there right now because I can see I'm up to almost 13 minutes, and so we'll pick up again with this tomorrow, and I will also be putting some more stuff up there for you to take a look at. Oh boy. Okay, talk to you later.